A message may travel across one cable, through your home router, or across thousands of miles of fiber before reaching its destination. What makes that entire journey possible? The equipment and connections that support communication are collectively called the network infrastructure. This infrastructure provides the platform over which data can travel reliably. Its physical components fall into three main categories: end devices, intermediate devices, and network media. End devices are the devices that originate or receive network messages. They form the interface between users, applications, and the underlying network. Computers, smartphones, printers, IP phones, security cameras, and servers are all examples of end devices. Another common name for an end device is a host. For network communication to work, devices must be identifiable. When a host sends a message, the message includes information identifying its source and intended destination. The network uses those addresses to move the message toward the correct device. Intermediate devices connect end devices and guide data through the network. A switch connects devices within a local network. A wireless access point provides network access over radio signals. A router connects different networks and chooses where traffic should be forwarded. A firewall applies security rules to permitted and denied communication. Network media provide the physical or wireless channel through which the message travels. Copper cables carry electrical signals. Fiber optic cables carry pulses of light. Wireless networks transmit information through radio frequencies. Wireless signals are invisible, but they are still a form of network media. Take a moment to think about your own home network. Which end devices are connected? Which device connects them? And are they using Ethernet cables, Wi-Fi, or both? An Internet Service Provider, or ISP, connects your home or business network to the wider Internet. The provider may be a cable company, telephone company, cellular carrier, fiber provider, satellite provider, or another organization operating or leasing access to network infrastructure. Some providers offer more than Internet connectivity. Depending on the provider and subscription, additional services may include email, storage, website hosting, automated backups, security features, telephone service, or television. No single provider owns the entire Internet. ISPs and other network operators interconnect through private links, transit providers, peering relationships, and Internet exchange points. Routers select paths using routing information, technical metrics, and business policies. The selected path is not always the physically shortest one. High-capacity provider networks form the major long-distance paths of the Internet. Fiber optic cables connect cities and regions, while undersea fiber systems connect countries and continents. Together, these networks carry enormous amounts of global traffic. A computer can sometimes connect directly through a modem, but that design may expose the device more directly to the Internet and supports only a limited home network. The more common design places a router between local devices and the provider connection. A typical integrated home router includes Ethernet switch ports for wired devices, a wireless access point for Wi-Fi devices, automatic IP address assignment, and basic firewall and address translation functions. Depending on the provider, the modem and router may be separate devices or combined into one gateway. Cable internet is commonly provided over coaxial infrastructure used by cable television providers. A cable modem processes the data signal and provides an Ethernet connection to the home router or local network. Cable service is normally always available without dialing a connection. Digital Subscriber Line, or DSL, carries internet data over telephone wiring. A DSL modem separates the data service from traditional voice service. The connection can remain active while the telephone is being used. DSL performance depends heavily on line quality, provider technology, and distance from the provider's equipment. Fiber service brings optical connectivity closer to or directly into the customer location and can support high bandwidth. Cellular connectivity uses a mobile provider's radio network and may connect smartphones or dedicated cellular routers. Satellite service can reach locations where wired options are limited, although performance and delay vary by system and conditions. Dial-up uses a traditional telephone modem and is now mainly a legacy option because of its very limited speed. The best internet connection is not determined by one technology name alone. Your decision should consider local availability, performance, reliability, latency, upload requirements, data limits, support, and total price. Connection availability varies by location. Urban customers may have several wired and wireless choices, while rural customers may rely more heavily on cellular, fixed wireless, or satellite service. Always compare the specific services available at the address. Let's recap. End devices originate and receive messages. Intermediate devices connect networks, forward traffic, and apply controls. Network media carry the signals. Your ISP connects your local network to other provider networks, and technologies such as cable, DSL, fiber, cellular, and satellite provide different ways to reach the internet. Look at this home connection. The laptop is an end device. The home router is an intermediate device. Wi-Fi is the network medium, and the cable modem provides access to the provider connection.